today we're going to talk about this next phase of web development and how web development has changed over the last couple decades and what we should be aware to make sure we're staying modern going into the future. First, let's go back in time a little bit to the original internet. And here's a quick diagram showing how that would work. The client, in this case the web browser, would request a URL, and that URL would say which server it needs to connect to, the domain, but also what on that server you're looking to get. So you'd request that URL, and the server would either grab a static file, or maybe it would go and build the file by hand using a language like PHP or Ruby on Rails, and render that HTML and serve that down to the browser, which would then just display the HTML for the end user. And that's how traditional websites have worked for a long time. It's how they still work today. And if you wanted to get data back and forth between the browser and the server, obviously you can pass it through the URLs as people clicked on links and went from page to page. But if you wanted to submit more data than that, submit a form, for example, you would actually use a form HTML element. So you would say form where the method that specifies how you're going to send the data. If you send it as get, it's going to be passed in as query parameters in that URL. If you do method post, it's actually going to do an HTTP post against the server. And then you specify all of the fields you might want to send over. So the server's doing its work, but the browser's really controlling the flow. It's controlling what the user sees. It's controlling when data is sent back and forth. And it's doing this through HTML and standard HTTP protocols. And if you've worked with a REST API before, you know that there's get, post, but there's also delete and patch, but those didn't usually come in for web development. Those came in more for APIs. And this is a great way of building websites, especially ones that are very content heavy. So things where there's very little interaction, and the main purpose is for the server to send a lot of information down to the end user, and that end user to be able to read the data. So things like a blog or a wiki or other content heavy sites. And as I said, we've been doing this a long time. But then JavaScript came on the scene. And JavaScript came on as a way to run code within the browser. And in the beginning, it was very UI focused, right? So we had a lot of libraries competing for attention, like MooTools, Dojo, jQuery, Scriptaculous, a couple more YUI, Next.js, etc. And they all included things like carousels, showing, hiding content, helping with DOM manipulation. It was all about giving interactivity to the HTML. It was all about fancy effects as you were navigating the page. And in fact, AJAX or API calls came later and got tacked on later on to these libraries. It wasn't a first-class citizen because originally they were designed for UI effects. And clearly we know our history. jQuery took over and won the library wars and really dominated the web for a long time. And today, if you still want to build this static type of website, jQuery is a great choice. Although now we also have Alpine.js, which is filling that role as well. That if you're having more of a server-rendered website and you want to add some effects into the browser side, these are two great options. But then single-page applications came around, SPAs. And SPAs did things very, very differently. So if we look at the flow chart, see that the client did most of the work, right? So let's zoom in a little bit. The client requests that URL, but now the server, instead of sending HTML with all this information in it, it's serving the application. It's really serving a blank HTML page with a bunch of links for where to find the JavaScript files, the JavaScript that's going to run that application. And now the browser gets all of this code, and it needs to run that code. And once it starts running the code, it's going to start executing the JavaScript. That JavaScript might need more data from the server, so it might make some API calls, getting some JSON. But it's up to the JavaScript to go ahead and create the HTML, to create the interactions, to even determine how the content changes from page to page. It's no longer about anchor links that request a new URL. It's JavaScript that's doing everything on the UI side. And this worked really well for applications. It makes sense. It's in the name, single page applications. So these weren't websites. Instead, these were apps or applications with classic examples like Google Maps, Gmail, social media, communication things that are extremely interactive. Sites and applications that you're going to load up once and you're going to spend a lot of time in there using the application. So if we go back to that chart, you'll notice it is very, very slow. The browser has to get a lot of data before that first render. But if you're creating an application, that's okay, because the user's willing to wait for that initial render because they know that they're going to spend hours in that app, and the added interactivity you get from doing it this way was worth the trade-off of having that initial load time, having that requirement of more memory on the server, etc. And this really started with two frameworks, Knockout and Backbone.js. They really started this idea of DOM manipulation, of building everything on the browser, but they quickly, inspired the frameworks we know today. Angular, React, and Vue. These are the leaders in single-page applications, and their names you probably already know. So with a traditional website, we talked about using forms and having the HTML in the browser manage how data got sent to the server. With these single-page applications, now we're doing a lot of API calls. What used to be called AJAX, although it's not XML anymore, it's typically JSON. And we did this for sending and receiving data. So instead of the browser controlling where the user goes, JavaScript does. So you have things like using the fetch API to get data or to send data to the server. But you also have browsers that, added the ability to set history through JavaScript. This was necessary because you're no longer using anchors to go from page to page. You're using JavaScript to change the screen. So you needed a way to re-enable that back button or to change that URL so that they want to grab it for later, bookmark it, send it to a friend, etc. That was possible. So you got this new window.history.push state in order to manipulate that through JavaScript. Because again, everything's going through JavaScript. So bonus, you often hear SPA and PWA, single page application versus progressive web app or progressive web application. And I think a lot of people are confused on what the difference is between the two. The difference is that progressive web app is making a reference to progressive enhancement. And if you don't know about progressive enhancement, I highly recommend you go read this blog post on a list apart. It came out years ago talking about progressive enhancement. And the idea is that you're providing a baseline functionality for any browser. So you're making sure everyone can use the content. But you're going above and beyond for those people that have devices and browsers that have additional functionality that you might want to leverage. And this became, progressive web app became a very popular term because SPAs and mobile were taking over around the same time. And there were some very mobile-centric technologies, very, very mobile-centric features like alerts, adding icons to the home screen, geolocation, maybe payment integration. And the mobile browsers were exposing this, but at the time the desktop browsers had no concept of looking up location. So it was progressive enhancement to say, our website will still work on a desktop browser, but when you're on a mobile browser, we're going to take advantage of these cool new features, which is why a PWA became synonymous with building a single page application with mobile support. But really, it's about anytime you're adopting features that may not be widely spread and you're leveraging it in your solution. So we've talked about what came before, what brought us to this point. Now let's talk about the next wave, okay? And before you had to pick a side. You were either on the server rendered side where you're building a traditional website, or you're building that SPA PWA. And everyone had to pick. So we're going to go JavaScript or we're going to go server rendered. And you had to choose. If if SEO was a major requirement, you probably went with a server rendered solution. If if you needed an experience that's more fluid or you're building an application, you really wanted to go with that SPA. So the problem is a lot of developers nowadays started in the React world. They went to boot camp or they went to university and they learned with React. So they want to use React. They don't want to build a traditional server rendered website. Or they're building a website that has both. It's very content heavy, but there's also these islands of interactivity that need to be supported. Like I work in the e-commerce world, so you have a lot of content heavy pages like product pages, but then you get to the cart and the checkout experience and it's highly interactive and you want that interactivity. So, a lot of smart people said, why not both? Why are we forcing people to decide? And so what happened is the SPA frameworks started borrowing all of the really good things from server rendered applications. And instead of having a choice, we now have a spectrum, where on the server rendered side, then you have static server-side rendering, which is often called Jamstack. You have things like partial hydration or pre-rendering plus hydration. And you have all this merging between what's going on the server and what's going on the browser. And you're now getting the best of both worlds. And in fact, the new frameworks take this to their logical end. And let's talk about that a little bit more. So first off, what do we call this? What is the name for it? I've heard lots of things thrown out. One, multi-page application. First off, we need to talk about multi-page applications because some people are using MPA to just mean, hey, you have a bunch of pages on the server and the browser selects them when necessary. Sorry, that's a website. That's not an MPA, that's a website. An MPA is when you have multiple pages and each one is their own individual application. So it's really like a bunch of little SPAs that are working together. So this really doesn't fit well for the naming. The other thing I've heard is hybrid frameworks. I like this one. I think it's a good labeling. We'll see whether it takes off. And the last one I've heard is transitional apps. And this was coined by Richard Harris, who's actually the creator of Svelte. And I believe this is the best description I've heard, which is this idea that the JavaScript code can transition between being server and being client, and it can move back and forth depending on what the business requirements demand. So I like the term transitional apps, but I don't think, the industry's settled on a final name for this. It might be transitional apps. Heck, it might just be JavaScript applications. We're going to find out. So some of the new crop of frameworks that you might have seen coming out. SvelteKit, already mentioned Richard Harris, but SvelteKit hit 1.0, and it's a very cool framework. I mean, Svelte, to start with, broke the rules by saying, hey, we're going to actually go through a compile step instead of just pure JavaScript. Remix, another one that we'll talk about. Astro, taking things very server-side with some unique features. And then on the bottom two, you see Next.js and Nuxt.js. And you've probably heard about these. They are meta frameworks, Next around React, Nuxt around Vue. And they're not new. They didn't come out with this new round. However, they have kept up. They have new versions that have adopted features that we're going to talk about. And some of the ones you might be thinking are missing are things like Solid Start. I have high hopes for this framework, but it's still in beta, so we'll see where Solid Start goes. Quick is another option. It falls under React, where we're already talking about Remix and Next. So I didn't want to go too far down the React world. And, there are more out there, and they keep popping up. And I appreciate the new ones. A lot of JavaScript developers go, man, couldn't we just have one framework to rule them all? And yes, we probably could, but these smaller frameworks come out and they break the rules. They don't have code debt, so they can do whatever they want. They can change the game. And then the bigger frameworks like Next and Nuxt look at that and go, that was a good idea. I'm going to add that into my next version. So I don't think we should bemoan that there are all these frameworks. I think we should appreciate the level of innovation that goes on in the JavaScript community. So let's dive into the specifics of some of these frameworks. First up, one of my favorites, SvelteKit. As I said, hit 1.0 last fall, ready to be used. Couple things to call out. First off, Svelte itself is compiled. So The Svelte language does not need to adhere to pure JavaScript. You can include everything and run it directly you can't include everything and run it directly in the browser the same way you can with Vue and React. So with Vue, React, Angular, and all those early libraries, the idea was that the browser was running everything. Your code, the framework code, all of it. You didn't need a compile step. But Svelte said, nope, there's absolutely a compile step. It is not going to work without it. And as a result, you end up with much smaller file sizes. You're not sending all of this, framework and library code down to the browser. And they can do some weird, simple things in the language itself. Things that aren't actually JavaScript, but are Svelte specific, but they're intuitive and they make the library fun to use. They make it great. Next up is that it's a full stack. SvelteKit is not a front-end framework. It is a full-stack framework. It's going to blend the back end and the browser, so you are expected to have a server side with this application. You can do full static rendering if your app doesn't require some of that server-side features, but it really works its best when you have some type of server to run everything on. And what's cool is it could be a traditional server, but it can also use edge functions across the CDN, which makes it even more powerful and even more performant. Server-side APIs, since it's a full stack application, you don't have to just build UI code. You can actually build your APIs directly in SvelteKit and keep your API code with your front-end code. This is great. It keeps all your code together. If you're building a small application, you're a JavaScript developer, you can now do everything yourself right in SvelteKit. If you're building a really large application consuming other APIs, this gives you the chance to add a backend for front-end layer into your architecture and not having a whole nother application to manage, deploy, etc. Instead, it's just your SvelteKit code getting deployed to the edge. It supports edge computing, I already mentioned that, and server rendering. So because you have server rendering, you can do everything you need to make sure you have an SEO-friendly website. So as you said, it gives you a blend of server technologies and SPAs and steals the best ideas from both. So let's go in a little bit on how it's building this out. First thing is that SvelteKit uses file system routing. In fact, a lot of these frameworks have moved into file system routing, where the files themselves and their folder structure define what the URL is going to look like, rather than you having to, mess with code matching or regex or anything else to figure out what the API routes are. So you have some special file names that you can use when building out your pages. They all start with a plus sign, which is a little controversial, but it does keep things very clear on what's SvelteKit specific. And your routes include the page itself. You can have a specific error page. You can have a layout page for the overarching layout of the website. And I think it's really nice to keep it separate. It does remind me of some older server-side frameworks. And then that plus server page, which says this is for running on the server only. And this is the kind of thing where you can define an API route. You can define an endpoint that you're going to call from the front end or from anywhere. And all other pages are going to be ignored by SvelteKit, so you can mix all of your other JavaScript code into those folders if you want to. Just don't put the plus in front of them. So, you can keep your code together logically if that's the way you want to do it. Or you can take any code that's shared between your different routes and put them in a special library folder that's $lib, and then they'll be shared between all the different routes. So let's talk about rendering it specifically. As I said, you have lots of options for rendering because it does have that server and the client side. So you can do this all through basic configuration in your page. So you can just, export a variable pre-render and say whether it's true or false. And this is going to determine whether, when you build your website, should it create a static file of that page, okay? And if you create static files, your initial load time is going to be super fast. Of course, you're giving up a little bit of flexibility on the updates because now you're making a static file rather than pulling it every time or composing it every time it's requested. Next one, server-side rendering. Can this page be rendered on the server, or should it only be rendered on the browser? So you can force it to work like a normal SPA by saying no, absolutely no pre-rendering, absolutely no server-side rendering. Or you can take advantage of it depending on what the requirements are. And the last one is client-side rendering. So you can actually set that to false and tell it, hey, this is just a server render page. Don't send any JavaScript down to the browser. Don't try and render it on the browser should they click to this page, this URL. Always go get it from the server. Which is great. And you can have a corresponding TypeScript or JavaScript file for each page. And having this allows data to be loaded before the page is rendered. So in the case of SSR, this data is being loaded on a server. Or in the case of CSR, it's getting called from the browser. And this offers you a fully generated types module, which gives us full type safety. It's giving you type safety between the client and the server, even though it might be going through a traditional REST call. So you now have type safety between your server and client, which is great. And if your data load has protected values or is using keys and secrets, you can just add .server into the file name, and it's going to tell SvelteKit, always run this on the server. Never, ever allowed this code to go down to the client. So that's a way to protect it and make it server run only. Okay, next up, I wanted to give some VS Code tips. I use VS Code for development, and when I first started using SvelteKit, there were certain things that just drove me crazy. And so I wanted to call out some tips that I saw online that I think are very helpful, that are worth talking about. The first one is changing the label format on VS Code so that you can see the directory structure and not just the page. Because you have all these plus page.svelte files, and if they're all open, you're not going to know which one's which. So by changing the setting, the label format to short, it'll show you, hey, this is the about page. And it gives you a little more detail up there. The next one I want to talk about is having the sort order set on your file list. And this one feels really weird at first, but as you use it, you realize how much better it is for SvelteKit. And you're basically going in and changing the sort order so it's files first and folders second. So the folders go underneath. And that allows you to see all the pages for your route before seeing the routes underneath, which is definitely a nice to have. So a couple of VS Code tips for those SvelteKit users out there. All right, next framework we're going to talk about is Remix. Very, very colorful logo. All right, let's get into Remix. Remix is a full-stacked React.js framework. It supports SSR, and it has a couple tricks up its sleeve, like nested routes and actions for forms. So this is ideal for any website with pages that don't have too much, that have a lot of dynamic data. So you don't want to do a Jamstack site because you want to pull it dynamically, but it is still a content-heavy page. And when I started using Remix, it reminded me a lot of the features from early in my career, those traditional server-side techs like PHP, classic ASP, Ruby on Rails, and it pushed those paradigms into the JavaScript world. And I give Remix credit because it took a lot of those great ideas, it added to a JavaScript framework, and now all the other players are popping up and copying from Remix. So first up is the nested routes. So you can have, if you're familiar with Angular, Ember, or PHP ASP applications, you might be familiar with this. Basically, you define an outlet, and when the URL changes, only that section of the page is replaced rather than the entire page. And these outlets can then nest in the application, allowing you to only focus on a specific section at a time. So you might dig into those routes. So you might start with your outer route, which is your root page. Then you might have an outlet for the sales section, which can control that part. Then when you go a little bit deeper into the sales section, you might have an invoice section that's its own outlet as well. And inside of that, you might have specifics about that, specific invoice ID. And as you can see, you can keep nesting these and nesting these. And as the route adds on to the URL, it's changing those intersections. And it's all based on that file-based routing that you're seeing change on the left. data movement and forms in Remix. So with a traditional SPA, you'd have to catch an event in a DOM anytime you're sending things to the server. So the person would click a button and you'd catch that button click, or they'd submit a form and you'd catch that form submit. And if you're using a form, you actually have to tell the browser to stop executing that form. That's that event.prevent default. And that says, hey, I know that in HTML, when you see a form and someone hits submit, you send it over to the server, but don't do that. Stop that, and I'm going to take it over with JavaScript, and I'm going to build it the way I think I want it to go, whether it's an API call or who knows what you're doing with the form submit. So you really have to circumvent how the web is supposed to work and do it with JavaScript in these SPAs. Well, Remix said no. Remix said, no, we're going to use forms and have them work the way we expect them to work by giving you a new form component. And this new form component, you use the default form action. And then it calls a defined function on the page. So the browser manages the form state. No longer do you have a need for managing the state of your form, for managing that virtual DOM. This takes away so much code. It simplifies the interaction. And it makes things like the form work even without JavaScript on the browser. So it is a really nice feature of forms in Remix. The other thing I want to call out about Remix is this idea of stacks. Stacks are pre-built, production-ready frameworks that include everything you would need, including a database setup, automatic deployment pipelines, authentication, testing, linting, formatting, TypeScript. Everything's basically built into these stacks. And it gets you up and running really fast with a production-ready application. And they already have a bunch built out that are fully supported by Remix, like the Blue Stack, the Indie Stack, the Grunge Stack. Yes, they're named after music genres. And so you can leverage these to get your application up and running faster with a production-level code situation, which is great if you're looking to get moving quickly without building out all of your boilerplate. Next up, let's talk about Astro. So Astro.js is cool in that it will actually let you use other UI libraries inside Astro. So they have their own way of writing UIs, but they also say, hey, you like Vue? Use Vue. Go for it. You like React? Do it. We're not going to stop you. Because Astro is designed to be server first. And it works with those existing UI frameworks, but by default, there is no client-side JavaScript. Instead, it supports server-side rendering, and when necessary, it offers selective or partial hydration. So let's get into that. In the Astro world, they call this Astro Islands, and they refer to interactive UI components on an otherwise static page of HTML that need that interactivity, that need that JavaScript. So multiple islands can exist on a page, and an island always renders in isolation. So you can think of them as islands in this sea of non-interactive HTML. You can think about these little pieces, these little islands that say, I need interactivity, I need client-side JavaScript, and the rest of the page does not. And each of those islands can actually be built with a different UI framework. I don't know why you'd want to if you're building it yourself, but hey, maybe you're looking to borrow something or transition code or who knows what that you're blending UI components, and you can do so with Astro. So, as I said, by default, you pull in a component, and that component has no JavaScript loaded on the page. But you can pass a directive. You can say client load, and this tells Astro to send the JavaScript for that island on page load. So when the browser loads the page, that section of it is going to get the JavaScript it needs to be interactive. But you don't just have to do it on load. You can actually give it client idle. And this says, hey, we're going to tell the browser to pull the code down when it's idle. When it has some time, that's when it'll go get the JavaScript and make that island interactive, which is great because it does not slow down the experience for the end user. And the last option is client visible. So this says, hey, I am going to load that JavaScript whenever this island gets scrolled into view. So for really long pages, this is probably where you want to go. You don't want to be loading JavaScript if you don't need to. Astro also allows for server-side endpoints, so you can create your own API directly inside the framework, and you're all set to go there, just like I talked about with SvelteKit. So the next thing we're going to do a little bit faster, since we're going to deep dive, and you probably already are familiar with these frameworks. So first up, Nuxt.js. I want to call out that Next.js has a brand new major version. That version is 3, and it's a total rewrite. And it includes a lot of new stuff that, is either innovative or borrowing from other frameworks. So it includes what they call universal rendering, which is the ability to transition from SSR, or server-side rendering, to a spa-like experience. Again, that blending of server and client. It offers hybrid rendering, which allows you to choose between server-side rendering, client-side rendering, or hydration, where it's a little bit of each. It has a full static mode, so if you want to go Jamstack, you're good to go there. And again, it has that file-based routing. So you can see that it's taking a lot of these same ideas of transitional apps and adding it to Nuxt.js 3. So if you're using Nuxt today, that upgrade is going to get you a lot of this transitional app functionality that you can now start to leverage. Next up is Next.js, which is also borrowing ideas from these newer frameworks and blurring those lines between client and server. So page-based, first off, Next 12. This is the version I'm talking about now. Next 12 has been out for a while, but it introduced some cool new things. Page-based routing is one of them. Static file server for Jamstack style websites. Server-side API routes. Again, so you can build APIs directly in your websites. You don't have to have a whole nother application with possibly a different language. You're just doing it right there in JavaScript, and you're deploying it out to your own server, or as I said, maybe even edge functions. Hybrid pages that offer both server-side rendering and client-side rendering. And Next.js 13 takes it even further by adopting React server components. So these React server components, they offer server-side rendering and improved hydration. So React's coming out with it, Next.js is adopting it. And better data loading. So the new convention is to load data on the server and send the rendered UI to the client. So really flipping the script from the original SPA that did everything on the browser and saying, we're really going to use the server by default unless it makes sense to use the client. So common themes as you start to look at these transitional frameworks and what's going on. So first off, for old websites, we put all of the code on the server. Okay? Everything lived on the server, and then we came up with single page applications. For single page applications, we moved most of the code onto the client. So old websites, basically everything ran on the server. SPAs, everything ran on the client, whether you like it or not. With transitional apps, we now have JavaScript code that runs both server-side and client-side, and this brings some possibilities that just didn't exist before. So it allows you to transition seamlessly. It allows you to have one language across your entire stack. And JavaScript is a lightweight language, which allows us to leverage things like edge computing and serverless functions and edge functions rather than full-blown servers. We can blend the experience from content to interactivity seamlessly. So in that original example of e-commerce, we can have a super highly interactive cart, either widget or island or whatever you want to call it, on a mostly static page that rendered super quickly and gave you that SEO that you needed in order to be successful in e-commerce. So for an SPA, the client needed all the code at once to execute. Now we can be smarter about what code we send down, which makes it faster initial load time. It makes smaller bundles. It makes everything a little nicer to use. So transitional apps are definitely changing the way we build things. And while some of these are new, like edge computing and hybrid rendering, many have existed for decades in the server-side web development space. So what was old is new again. So all the skills that we learned before SPAs are now relevant with these new transitional apps. And unfortunately for you programmers that started with SPAs, that started with just React, you're going to have to go back and learn some of the other techniques. But it's all going to be in JavaScript, so hopefully it'll be an easy transition. So I think what's most exciting is we no longer have to choose between traditional websites or single-page applications. We can just have the best of both options, right inside of our JavaScript code. We can just pick and choose on a component or page-by-page basis and build the experience that the end user wants, not the one that's dictated by the tools we use.